Hello students, welcome to Educate. Today we are going to do numericals on chapter number 9. So let's see the questions. Question number 9.1 says, explain why the blood pressure in humans is greater at the feet than at the brain. So it is simple. Pressure depends on rho GH. Obviously, here suppose H is 0, we are talking about head, and here it is feet. So their difference, suppose say 1.70 meter height. In that case, there will be pressure due to this much height of blood at the feet. But here height of the blood vessel will be 0. So there will be a great difference between the pressure level. So that is why the blood pressure in humans is greater at the feet than at the brain. Atmospheric pressure at a height of about 6 km decreases to nearly half of its value at the sea level, though the height of the atmosphere is more than 100 km. Here, general formula, if we consider, then we have already calculated that height of atmosphere is about H equal to 8 km, and that is not true. The same statement they are saying that atmospheric pressure at height of about 6 km decreases to nearly half of its value at sea level. So here at sea level, suppose atmospheric pressure is 76 cm of Hg. They are saying that after reaching around 6 km, this becomes just half of whatever value, like here Pa, we get how much? Do you remember? 1.013 into 10 power 5 Pascal. So they are saying that half of this value at 6 km. So we can say that density of air does not change uniformly, means there is no linear change, right? That is why up to here also there is air, till 100 km air is found. So there will be certain pressure here also at this point. So this is because of non-uniform density of air, right? Then hydrostatic pressure is a scalar quantity even though pressure is force divided by area. If we consider hydrostatic pressure, so it has no definite direction. Suppose we consider a cube and we put it inside a container containing water or any other liquid, then pressure will be from this side, pressure will be from in this side, from this side, from this face, from that face. So direction is not certain in which direction it is acting. At every surface it is perpendicular. So that is why it is a scalar, because in case of vector there is definite direction. If we talk about weight, so we say weight is toward the center of earth. So that is why we say that hydrostatic pressure is a scalar quantity. Now explain why the angle of contact of mercury with glass is obtuse while that of water with glass is acute. So what are the factors that decide the angle of contact? Suppose we take a glass and we fill liquid in it, here say it is water. So when we talk about angle of contact, this angle theta, we say it is, obviously this is acute. So what is happening? So there are two types of forces here. One is cohesive force. Cohesive force means force between same types of molecules. So water molecules they are attracting each other with a force that will be cohesive force. And there will be adhesive force. Water molecule and this, suppose container is of glass. So glass plus water. So this force will be adhesive force or force of adhesion. So if adhesive force is greater than cohesive force, in that case angle will be acute. On the other hand, if cohesive force is stronger than adhesive force, then angle will be obtuse. As in case of mercury, what do you observe? So angle of contact will be like this will be obtuse, right? It means cohesive force between molecules is larger than the adhesive force. So I think you have understood. The angle of contact of mercury with the glass is obtuse, while that of water with glass is acute. Water on a clean glass surface tends to spread out, while mercury on the same surface tends to form drop. This is same thing. So here, what is angle of contact? This will be acute, but in case of mercury, it will become obtuse. So here theta will be obtuse, right? So it will not wet, whereas this will wet the surface. So that thing is given here. I think you have understood. Now let's go to next point. Next question is, surface tension of liquid is independent of the area of the surface. What is formula? Surface tension, if we denote surface tension as S, then it will be F upon L. If there are two free surfaces, then we can write here 2L, but just F upon L. So here is area involved. Here they are saying area of the surface is not involved, independent. So yeah, it's true. Next one. Second point is viscosity of gas. What will happen? Gas molecules, if you heat it, suppose they are contained in a container, then they will try to move closer to each other. So it will increase, while that of liquid will decrease. Then for solids with elastic modulus of rigidity, the shearing force is proportional to, while the fluid it is proportional to. So in case of, if you remember, when we consider eta, we write force upon area divided by deformation produced divided by side, suppose L. So this is shear strain. When we talk about solids, then we say that shear modulus is given by stress or force upon area divided by deformation produced divided by original side. But in case of liquid, rate of shear strain is considered. In that case, what do we take? We take delta x upon L times T, or we can say it is V upon L, velocity gradient. Next point is, for a fluid in a steady flow, the increase in flow speed at a constriction follows. So if you remember, suppose you have a tube like this, and here area is A1, here area is A2, here velocity is V1, here velocity is V2. So according to continuity principle, A1 V1 is equal to A2 V2. If A2 is less, then V2 will be more to keep the product same. So this is due to continuity principle. Here question is, what does the question say? For a fluid in steady flow, the increase in flow speed at constriction follows conservation of mass per Rowley principle. So here what is happening? Continuity principle is based on conservation of mass. No mass accumulates, that is why speed is increased. And then comes next question. For the model of a plane in a wind tunnel, turbulence occurs at, for turbulence for an actual plane. So if you remember it, so what is the concept? When there is, if you remember, I told you that if there is a flow that is called laminar, or you can say streamline flow, and if turbulence is to occur, then the speed must go to certain value, or it must exceed a certain value, that is critical speed, right? So greater speed for turbulence, right? Then comes question number 9.4. Question says, to keep a piece of paper horizontal, when you should blow over, not under it. Of course, if you blow over it, then what will happen? Actually, what happens if you take a piece of paper, then if you hold it, then it will become like this. But if you blow air here, then what will happen? Here pressure will decrease. So hence this will be attracted upward. It will move towards the less pressure. So this is the reason. Then when we try to close a water tap with our fingers, fast jets of water gush through the opening. It is obvious. Suppose this is opening and now there is very small fine pore, or many pores are there. Then ultimately mass will remain conserved. So according to continuity principle, velocity must increase. Since areas are very less, that is why speed will be higher. So fast jets of water will gush through the openings between our fingers. The size of the needle of a syringe controls flow rate better than the thumb pressure exerted by Dr. Weil. So here flow rate means what? Velocity. So in Bernoulli theorem, second power of velocity is involved. If you write it like pressure plus 1 by 2 rho v square plus rho gh equal to constant. So here second power is involved. So this is the reason question says the size of the needle of a syringe controls flow rate better than the pressure exerted by Dr. White administering the injection. So this logic. Now the fluid flowing out of a small hole in a vessel results in a backward thrust on the vessel. So here you can say conservation of linear momentum. So like in case of you have studied, when gun is fired, then it gives a backward jerk. The same happens here also. In that case also momentum remains conserved. The same happens here. Now, a spinning cricket ball in air does not follow a parabolic trajectory. We have already studied. Suppose here this ball is spinning, then what will happen? Speed, if you consider the speed. So what happens? The air in contact with ball will move faster here. So in one side it will move faster, and in other side it will move slower, because here what will happen? A flow of air is like this. So here its speed will increase because this is spinning like this, right? But here it is going opposite, so its speed will be less. So here what happens? Since the speed is more, so according to Bernoulli theorem, total energy remains constant. So in that case pressure will be less. So it will feel little upward force. So that is why its trajectory will not be normal as we expect. Now, next question. A 50 kg girl wearing high heel shoes balances on a single heel. The heel is circular with a diameter of 1 centimeter. What is the pressure exerted by the heel on the horizontal floor? So what is concept involved? If you remember, pressure equal to force upon area. So force is given 50 kg girl. So 50 into 10, or just write 9.8. And as far as area is concerned, so circular path, diameter this, circular with diameter 1 point. So you can say pi times radius will be 0.5 into 10 to the power minus 2 whole square. Then you can simplify to get the answer. Here answer obtained will be equal to 6.2 into 10 to the power 6 Pascal. So fifth question you have understood. Now let's go to next question. Torricelli's barometer used mercury. Pascal duplicated it using French wine of density 984 kg per meter cube. Determine the height of the wine column. So here what is the concept? Here concept is, you have seen that mercury rises up to 76 centimeter in a tube, right? So up to here 76 centimeters. So we say that atmospheric pressure is equal to 76 centimeter of mercury column. So we write P equal to rho GH. Here another liquid is there and we have to find out what is height. So we can write rho 1 GH1 equal to rho 2 GH2. Our concern is to get H2. So H2 equal to rho 1 GH1 divided by rho 2 G. G will cancel out. You will be left with rho 1 H1 divided by rho 2. Let's write the values. Rho 1. Rho 1 means we are taking mercury. Its density is 13.6 into 10 power 3. H1, its height is 0.76 divided by rho 2. In our question, rho 2 is given, whose density is 984. So just write here 984 and try to evaluate it. On evaluation, what do you get? It will be 10.5 meter. Right? You can do the calculation. Should we proceed? So we have done this question. Now there is next question. A vertical offshore structure is built to withstand a maximum stress of 10 power 9 Pascal. Is the structure suitable for putting up on top of an oil well in the ocean? Take the depth of ocean to be 3 km and ignore ocean current. So here we have to check whether pressure exerted by 3 km high water column is exceeding 10 power 9 Pascal or not. If not, then it is suitable. So P equal to rho Hg, right? So rho is rho of water, say it is 1000 into height is given as 3 km, that is 3000 into G, let's take 9.8. So obviously total strength is for design is 10 power 9 Pascal. It cannot be 10 power 9. So if we evaluate it, it comes out to be 2.94 into 10 to the power 7 Pascal. So clearly here the structure is able to withstand till 10 power 9 Pascal, whereas the value coming is just 2.94 into 10 power 7 Pascal. So yes. Now let's consider next question. So we have reached till this 9.8. So what is 9.8? A hydraulic automobile lift is designed to lift cars with a maximum mass of 3000 kg. So here mass is given 3000 kg, or we can write force is 3000 multiplied by 9.8 Newton, right? Area of cross section of the piston is this much, 425. Area, say right, A1 425 into 10 to the power minus 4 meter square, right? Because it is in centimeters. What is maximum pressure? So pressure is to be found force upon area. So just put the values, 3000 multiplied by 9.8 divided by 425 into 10 to the power minus 4 and evaluate it. Take 1 minute to evaluate. I will write the answer. it is 6.92 into 10 to the power 5 Pascal, right? So you can do it easily. Now let's consider next question. A U-tube contains water and methylated spirit separated by mercury. The mercury column in the two arms are in level with 10 cm of water in one arm and 12.5 cm of spirit in another arm. What is specific gravity of spirit? So did you understand the question? The question is like this. Suppose you have a U-tube like this, and here up to here on both sides there is mercury. So mercury is in level, so that does not matter. Up to this height there is the mercury column in two arms are level with 10 cm of water. So here this is filled with water, H2O, right? The H2O is 10 cm, whereas in this arm there is methylated spirit, isn't it? 12.5 centimeter. So what we can say? We can say pressure exerted by pressure due to 10 cm water is equal to pressure due to 12.5 cm methylated spirit, right? So concept is simple. So rho 1 GH1 equal to rho 2 GH2, right? So GG will cancel out. Rho 1 for water is 1000 into height is given as 10 cm. So 10 by 100 equal to rho 2 is not known and H2 is 12.5. So you will get rho 2 equal to, just evaluate it. You will get as 800 kg per meter cube. If you want to find out specific gravity means relative density. So density of substance 800 and density of water is 1000. So this will be 0.8. I think you have understood. So we have done till 9.9. 9.10 onwards we will do in next lecture. Thank you for watching. Team Educate